Glaciers. This is all stuff you need to know. Reference table, not going to help you with glaciers really. Let's go. So, some things about glaciers. Glaciers are moving ice. The deposits from glaciers are going to be unsorted and the sediments will be angular. And some of the features of glaciers, just some, there are more, but the key ones are U-shaped valleys, drumlins, striations on the bedrock, which is like parallel grooves, kettle lakes, moraines, outwash plains. Let's get into it. So, first thing, if you have a mountain glacier or a valley glacier and it's going through a valley, there's so much force, so much erosion of these glaciers that the shape of the valley is very U-shaped. Hopefully you can see this is a photograph of a real location. The U-shaped valleys here, so you know that was a glacier, not a river. A river forms a V-shaped valley. So here's another picture of it here. And again, I hope that this comes through clearly. A U-shaped valley. Again, I know a glacier formed this. Because it removes so much sediment and it ends up being in that U-shape. U-shaped valley glaciers know it. Now, this is showing not a mountain or valley glacier like formed U-shaped valleys. This is a continental glacier. And in this case, it is melting back or retreating, okay? This is really a focus because all of New York State was covered in 1 mile thick of ice, 15,000 years ago, 20,000 years ago. And so much of it, what we see of New York is glacially formed. That's why it's important. So a few things here. As this glacier when it's moving forward, going over the bedrock, there's a lot of rocks and boulders frozen in the bottom of it. And then it moves along. I've heard it described as like ice-filled sandpaper. And it can scratch the bedrock beneath it. And that forms, hopefully this is a picture from a Regents exam. You see these lines that go this way, okay? It's usually it looks really flat. Almost as if people did this, and his lines going this way. These are called glacial striations. They're parallel grooves, and it shows the movement of the glacier was in this direction or this direction. Definitely not that way. As a matter of fact, I took a cool video in Saugerties, New York, of this location showing it. Let's watch it now. So this diagram shows a continental glacier, the kind that covered New York State 20,000 years ago, the kind we currently see in Greenland, Antarctica today. Now in this case, this glacier is retreating. It has melted back quite a bit. Let's look at some features here. So I know that it went this far because right here is a terminal moraine. A moraine is any line of sediment deposited by a glacier. So like this is a moraine too. It's in the middle of a glacier, a medial moraine. But now this shows that the glacier came this far. It maybe stopped here for a little bit, so the glacier kept bringing sediment down, sort of like a conveyor belt, and depositing it there. This sediment is going to be angular and unsorted. It doesn't have any abrasion, not rolling on the bottom of the stream or with waves. It gets frozen in the ice and kind of stuck there. So angular, unsorted is the glacier, any sediment deposited directly by glacial ice. Know that. Let's see what other features. Oh, so I want to show terminal moraine, a good example. There are, Long Island, New York is basically all glacial deposits from the last ice age, which ended maybe 10, 12,000 years ago. And here they're separated out into separate moraines, the Ronkonkoma moraine, the Harbor Hill moraine. That's important to know because so many people live on Long Island, and that's the origin of it, glacial deposition, which is pretty cool. Okay, the other thing you see here is drumlins, and drumlins are these elongated hills, usually steeper, sort of on the side of the glacier. It came this way, and they kind of showed glacial movement. So here is a diagram from a Regents exam. It has a key here, and basically it gets stretched out. So it means the glacier it was these sort of piles of sediment that got ran over by the glacier going this way. Sometimes it can be hard to tell, but the glacier either went this way or this way, but it definitely didn't go that way because it kind of elongated these hills. So those are drumlins, and this is upstate New York near Oswego, Lake Ontario. So New York State has a number of these, and this is a prime example of it. Kettle lakes are another feature of glaciers, really melting glaciers. So when a glacier is melting, you often have these large blocks of ice that are, half the size of our school even. And what happens is, as there's a lot of meltwater, so the ice will be a huge block, and then sediment will build up around it as all the water washes a lot of sand around it, but the ice is still there. give the ice a few hundred years, it will melt, and there'll be no sediment here, and then it fills in with water, and it's a lake. It's called a kettle lake, and oftentimes where there was a glacier, they see a lot of these kettle lakes all kind of scattered around. Some can be pretty decent sized, but they're usually pretty small lakes. Another feature, a glacial erratic. These are big boulders that were deposited by the glacier. A glacier can move huge boulders the size of my car, way bigger than the size of my car sometimes, because it gets frozen in ice, and the ice will carry it sometimes hundreds of miles, and wherever the glacier melts, it just drops it right there. It's called a glacial erratic. Here's a photograph of one, and often this rock is probably very different than the bedrock in the area. May come from hundreds of miles away. Cool, glacial erratic. Now, what we see here is we're going to change gears a little bit. Not change gears, but another part of glacial deposition, this makes it a little confusing, is not the sediment deposited by the ice, but the melt water of a glacier. A glacier has a lot of water melting off. Now, that's not going to move boulders the size of my car. Okay, it's going to move pretty much just sand and small gravel and stuff like that. So this area here, this is called the outwash plain on the other side of the terminal moraine. This is all deposited by the water. Okay, so it's really kind of sand, usually pretty well sorted. Here I have a photograph of one, which really shows, in this case, here's the glacier. You see all this melt water running off, okay? And what you get are these kind of braided streams. It's really kind of flat, and a lot of sediment, a lot of sand-sized sediment. And so this is the outwash plain. So you really have to be able to determine the difference of whether it's the water coming off a glacier that's going to be more smaller sediments that are sorted, or deposited directly by glacial ice, angular, unsorted, and can be quite large. So that makes it a little tricky. So here we go. Deposition by the water from a glacier, sorted sediment. Sometimes you get these braided streams here because there's so much sediment. So that's a cool feature of it. Let's see. I'll just throw one question at you. This was a question from a Regents exam. It did say these are out of order, and what you had to do is put the diagrams in the proper order to show Kettle Lake formation. Okay, so the first one here is going to be this, right? So there's a block of ice, then it got buried with sediment, then it got buried with more sediment, okay, and then the last one, it melted, and then you have a lake. So I drew them in here. So this is the first one, then step 2, buried by sediment, buried by more sediment 3, and it ends on number 4. You have a kettle lake. That is glacial erosion and deposition. Thanks for watching.